Hi, I'm Abigail Hendershot, Executive Director of the Michigan PFAS Action Response Team. I'm glad you've joined us today to talk about PFAS basics and your health. So we're going to walk through some basics of PFAS. And specifically, we're going to start with what MPART is, because it's important for you to know. MPART is the Michigan PFAS Action Response Team. Started as an executive order in 2019. It really lends itself to this very unique multi-agency approach that leads to cooperation and coordination of PFAS issues across the state. Helps us direct our implementation of PFAS investigations and public health responses. MPART is made up of 7 different agencies, including the Michigan Department of Environment, Great Lakes and Energy, Michigan Department of Health and Human Services, Michigan Agriculture and Rural Development, the Department of Natural Resources, Department of Transportation. LARA is our Fire Marshal's Division, and then the Department of Military and Veterans Affairs. So what is PFAS? PFAS is an acronym for a family of compounds called per and polyfluoroalkyl substances. They have very strong, they're one of the strongest naturally, one of the strongest bonds, chemical bonds in nature. It's a very strong carbon-fluorine bond, and it makes a lot of different products very convenient for us because they repel water, oils, fats, and grease. We started developing them in the late 1940s. They continue now. We have thousands and thousands of compounds now that use PFAS substances for commercial uses. So some of those uses include the Scotchgard carpets, our carpet cleaning products, food packaging, our furnishings. You might have been asked if you wanted your couch Scotchgarded before it came home, your cosmetics, your outdoor gear where you have waterproofing, your Gore-Tex clothes, adhesives and sealants, your waterproofing your shoes, some of the early day Teflon pans, and then firefighting foam, specifically AFFF Class B foam is, because not all firefighting foams are PFAS containing. Those they use for wood fires, for structure fires, are different than those that they use for petroleum fires. So why are we concerned? Why are you here today to hear about PFAS? PFAS are widespread in the environment. We're finding them finding PFAS in a lot of different medias, including the groundwater, the soils, and surface water. And PFAS does not naturally biodegrade. We don't see that it's going to break down naturally in the environment. And we are finding that it actually does. Some of the PFAS will actually bioaccumulate in our bodies and in fish, which you will hear about here in a second. Some of the PFAS we know do have health effects, which is why we are here today to talk to you about it. And there's a information being developed and research happening on PFAS, but that information is still in the early stages. And so at this point, we're still investigating. There are state standards for PFAS for 7 different compounds, but at the federal level, there are no PFAS standards set by EPA or any of the other federal agencies. So this diagram here shows you some of the ways in which PFAS can circulate throughout our environment. PFAS can be emitted from a industry that might use or produce PFAS. It might get directly into the ground or into the stream, and then it might go through a wastewater treatment plant. The wastewater treatment plants are not designed to treat PFAS, and so that PFAS will pass through the plant and enter into sludges or into the direct discharge to a stream and or to biosolids. There's many different ways in which PFAS circulates. We want to be able to cut those off. I'll just mention a few other things. There's a lot of ways here you'll see on this diagram where PFAS can enter the groundwater in the rivers, which can be a source of water for drinking water for homes. And so there's a lot of opportunities for that contamination to happen, which is why it's important that people understand what they are drinking and understand those influences. Residential homes also have sources of PFAS in them, as we talked about. And so there is, some evidence that septic fields also contain levels of PFAS. So it's a very complex system in our ecosystem for PFAS, and MPART's job is to try to understand and study those occurrences and figure out best management practices for breaking the PFAS cycle. So part of the MPART work has been to investigate sites around the state, sites that include military bases, landfills, chrome platers, airports, automotive facilities, etc. Sites where we know we have sources of groundwater contamination for PFAS, and sites where the nearby residential drinking water wells are being evaluated to ensure their safety from PFAS sources. These kinds of sites usually involve investigations of other pathways, including surface water for soils, groundwater movement, etc. And here is Bill Farrell to talk to you about PFAS and health.
Thanks, Abby. Hi, everyone. My name is Bill Farrell. I'm a toxicologist with the Michigan Department of Health and Human Services, and I'm going to talk a little bit about PFAS and health. Next slide, please. So how are you exposed to PFAS chemicals? The main route of exposure, the most significant route of exposure, is typically ingestion of PFAS. Drinking contaminated water. The sites that we're working at across the state, the most significant exposures that we're finding are PFAS in people's drinking water wells. Also, as Abby mentioned, PFAS can bioaccumulate not only in humans, but also biota. So eating fish caught from water contaminated by PFAS is another potential route of exposure to PFAS chemicals. Michigan Department of Health and Human Services issues Eat Safe Fish consumption guidelines. And you can find information on that at the website michigan.gov/eatsafefish. Incidental swallowing of contaminated soil or dust is another route of exposure. Eating food packaged in materials containing PFAS. Using some consumer products is another route of exposure. And PFAS absorption through the skin is typically not a concern because PFAS chemicals are not easily absorbed through the skin. Next slide, please. So as we mentioned before, PFAS bioaccumulate in humans. And this slide shows the average concentrations of several PFAS chemicals in the blood of residents in the United States over time. And this slide comes from a study done by CDC. It's called the National Health and Nutrition Examination Survey. And what that is it's just a study that's been going on for years where they study the nutritional habits of people in the United States. And as part of that study, they also collect blood samples and analyze the blood samples for chemicals that are known to bioaccumulate. And in 2000, they started collecting blood samples from residents in the United States and analyzing those blood samples for PFAS. And I want you to pay particular attention to this slide, the upper line in green, and that shows the average PFOS concentration of residents in the United States beginning in 2000. As you see, in 2000, the average concentration was about 30 micrograms per liter. And then you move to 2014, you see there's been a decline in the average concentration to around 6 micrograms per liter. And the reason for this is that in 2002, the United States stopped the use and manufacture of two specific PFAS, PFOS and PFOA, in products that were manufactured in the United States. So as a result of stopping the use of those two particular chemicals in the United States, you saw a decline in exposure. And as a result, you see a decline in the average concentrations in residents in the United States blood over the years. Next slide, please. So most of what we know about associated health effects associated with exposure to PFOA and PFOS come from studies of animals and human epidemiological studies. And this slide shows some of those associated health outcomes. And they include reduced fertility, high blood pressure or preeclampsia in pregnant women, small decreases in infant birth weight, higher cholesterol, especially total cholesterol and LDL cholesterol. Next slide, please. Thyroid disease, liver damage, decreased immune system response to vaccines, developing certain types of cancer, in particular kidney and testicular cancers. Next slide, please. So when we investigate these PFAS sites, we typically work with the local health department to evaluate results and make public health determinations. Some of these public health response actions could include no public health actions necessary. We may recommend the use of alternative water, a filter alternative water. And typically, in a lot of cases, the filter is provided because we need time to conduct more investigation. We need time to understand if levels could change over time, if levels could fluctuate. So the filters provide us with that level of protection while we can continue to do investigation in the area. And another response may just be education, providing people with information on PFAS in drinking water. Next slide, please. And as I mentioned, one of the response actions that we may provide is a point of use filter. A point of use filter is a filter that you install usually under the kitchen sink or wherever you get your drinking water. And what it does is it filters water that you use for drinking and cooking, because as I mentioned, typically other household uses water for like washing dishes, laundering, bathing, showering. It's not a concern. It's typically, we're just trying to reduce the exposure where you get the greatest amount of PFAS, and that's through drinking water. And when we provide point of use filters, we provide filters that are certified to remove PFOA and PFOS. And the certification is a specific certification referred to sometimes as a P473 certification or an ANSI 53 certification. So if you are interested in for your own purposes, looking at providing a filter, using a filter or something, you want to make sure that you get the filter that's certified to remove PFOA and PFOS.
Hi, I'm Sydney Rahala. I'm a geologist with the Michigan Department of Environment, Great Lakes, and Energy, and I'm here today to talk about the Wixom Wastewater Treatment Plant Land Application Sites Investigation. If you have any questions, please feel free to reach out to me at my contact information provided on the slide. The Wixom Wastewater Treatment Plant received elevated concentrations of PFAS from an industrial user to their system. PFAS sampling at the wastewater treatment plant found high levels of PFAS in the treated wastewater and biosolids. Biosolids are the nutrient-rich organic materials resulting from the treatment of domestic sewage in a wastewater treatment plant. Biosolids are a beneficial resource, contain essential plant nutrient and organic matter, and are recycled as a fertilizer and soil amendment. Under EGLE's Water Resources Division, the City of Wixom has an approved residuals management plan, which has allowed the wastewater treatment plant to land apply biosolids generated at the plant onto farm fields since July of 2000. However, it is worth noting that the Wixom wastewater treatment plant is currently landfilling their solids and has been since the fall of 2017. Due to the high concentrations of PFAS detected in the biosolids, the Water Resources Division sampled 6 land application sites, or farm fields, for PFAS that received biosolids from the Wixom wastewater treatment plant. As you can see on the map, there are 6 farm field locations that were investigated, and in the southeast corner, you can see the Wixom wastewater treatment plant. This presentation will focus on 4 of the 6 farm fields as shown by the yellow circle on the map. These fields are located south of Golf Club Road along South Kellogg Road in Howell, Michigan, approximately 18 miles west of the Wixom wastewater treatment plant. As part of the investigation, EGLE installed 6 groundwater monitoring wells across 2 of the farm fields to investigate PFAS in groundwater. At each location, 1 deep well and 1 shallow well were installed as shown by the blue and white circles on the map. The groundwater monitoring wells were originally sampled in September 2019. At that time, PFAS was not detected in any of the deep wells. PFAS was detected in 2 of the shallow wells, that is the well in the northeast corner and the well to the south. However, the reported values did not exceed groundwater protection criteria. In addition, 4 residential wells and a livestock well near the fields were also sampled for PFAS in September 2019, and PFAS was not detected in any of those 5 wells. The groundwater monitoring wells were sampled again in March 2021 to observe fluctuations in PFAS over time. In March 2021, PFAS was detected in 1 of the deep wells and 2 of the shallow wells, again, the well in the northeast corner and the wells to the south. This time, PFOA, or PFOA, was detected in the shallow well on the southern edge of the field above groundwater protection criteria. Note, estimated groundwater flow direction across the fields is to the northeast, as shown by the blue arrow on the map. At this time, EGLE does not have data showing that the PFAS contamination has moved off-site. However, due to the March 2021 results and the detection of PFOA in shallow groundwater above protection criteria, EGLE, the Michigan Department of Health and Human Services, and the Livingston County Health Department have decided to expand residential well sampling on the north, east, and south side of the farm fields out of an abundance of caution to ensure protection of public health. The precautionary residential well sampling is planned for homes along Golf Club Road and South Kellogg Road, as shown in the yellow areas on the map. So what do you need to know about residential well sampling? Sampling will be done at no cost to the homeowner. Letters will either be hand-delivered or mailed to the residents. Sampling will be done by an EGLE contractor. That contractor will wear a badge, as shown on the right, while in the field. And sampling can be done at an outdoor spigot if available. EGLE, the Michigan Department of Health and Human Services, will evaluate results and expand the sampling if needed. The Michigan Department of Health and Human Services, working with the local health department, will also coordinate any health response needed. If you are interested in having your well tested for PFAS, please complete the access request form provided to you in the letter and email or mail the form to the contact listed. EGLE staff or their contractor will contact you before they arrive to collect your sample. If you have any questions, again, please feel free to reach out to me at my contact information provided on the first slide. Thank you.